Okay, our next cartography topic is moving on to a different kind of coordinate system, which is a lot easier to use than latitude and longitude. So our geographic coordinates, remember, are spherical coordinates, so they're in angles, and they can be really cumbersome for computing distance, and it's hard to sort of know, to visualize, like, oh, it's 2 seconds different, and, how far is that? And remember, the distance of a degree or a minute or a second of longitude varies with your position on the globe north-south. So if you're further north, if you're at a higher latitude, then the distance represented by a degree of longitude is much smaller than if you're at the equator, because remember, the lines of longitude converge as we go to the poles. So it varies depending on where you are for longitude. For latitude, it's the same. So anyway, a solution, instead of using latitude and longitude, is to apply a grid, like a Cartesian coordinate grid, to a projected map. So we use a projection to project the area that we want to map with as little distortion as possible, and we put an XY grid on that projected map. And so now, if we have a point here, so here's our point, and we want to know the coordinates for that point, we go to the axes and we get our coordinates. And they'll be in feet or meters, a unit that's a lot easier for us to understand and a lot easier to use. So we have our grid. Our easting is the x-axis, our northing is the y-axis, and usually our origin, our 0, 0, we place way to the southwest, so that we're always using positive coordinates. So we don't want to have to deal with negative coordinates. So we want to make sure the origin of our graph, our grid, is placed far to the southwest so that we only have positive coordinates. So the grid coordinate system, or often it's called a projected coordinate system. When you do your georeferencing in ArcGIS, you'll tell it it's a projected coordinate system, is the Universal Transverse Mercator System, or UTM grid. And so this is a grid placed over the transverse Mercator projection. So remember, a Mercator projection is a cylindrical projection where the cylinder is wrapped around the globe transversely so that the line of tangency corresponds to a meridian or a line of longitude. And the UTM coordinate system is going to give you your horizontal position in northing and easting in meters. It was adopted by the Army in 1947, and it covers the Earth from 80 degrees south to 84 degrees north. There are different grid systems for the poles, so we can't use the UTM grid at the poles. And what they did with the UTM grid system, which I think is actually a really cool idea, instead of projecting the entire globe on one map, they project a 6-degree wide strip, 6 degrees of longitude wide strip, using that using the transverse Mercator projection. So we use the transverse Mercator projection to project a little skinny strip of the globe, and they put a grid on the northern half of the strip and a different grid, different coordinates, on the southern half of the strip. So we have 60 of these north-south running strips around the globe. Each strip overlaps the next strip by a half a degree. So remember, the least amount of distortion is along that line of meridian, along that line of tangency of the cylinder's connection to the globe. And so what we're doing is projecting these little strips, and here, let me show you. Here are our UTM zones. So we have 1 to 60, and here's the equator right here. So there are in total 120, right? Because you've got 60 northern grids and 60 southern hemisphere grids. Interesting thing for us in Colorado here, and we're in zone 12, and we're north of the equator. So the UTM zone for Grand Junction is zone 12 north. Most of the state of Colorado, including Denver, where a lot of the federal agencies have offices and our state government agencies have offices, are all in zone 13. Coordinates for a point in the UTM zone 12 grid well, if you take those coordinates and try to plot it in zone 13 without transforming them, it will plot in the wrong place. So you have to be careful about that. Another really goofy thing is they do have some north-south designations, which are not necessary, because really all you need is are you north or south, and what are your coordinates? So you don't need to say we're in W, we're in zone 12W. But on your Garmin, it will tell you you're in zone 12S here in Grand Junction, which is just a little bit confusing because S can also be used to represent zone 12 south. But we are in zone 12 north, UTM zone 12 north, and we happen to fall in this S category, which I think is really goofy that they left N and S in there, but they took out I and they took out O. So I don't know. I don't understand that. But so really all you need to say is give the northing and easting UTM zone 12 north, and that should take care of it. So here we are. Here's our location here in Grand Junction. You can see most of the state of Colorado is in zone 13. We are just on the eastern edge of zone 12. The origin, the 0, point for the UTM zone is all the way down at the equator and a little bit west of the western boundary of the zone. So at our latitude, your UTM northing should always be a bigger number than your UTM easting, because it is much further to get to the 0 for the northing than it is to get to the 0 for the easting, because the 0 for the easting is just right over here. So it's for us it's about 700,000 meters or 700 kilometers, whereas our northing is 4,300,000 meters, which is 4,300 kilometers. So our northing is going to be a bigger number than our easting. So each UTM zone has a central meridian. Each zone is 6 degrees wide. So for example, zone 14 is at 99 degrees west of longitude, and that's the central meridian of the zone. So it extends from 96 degrees west of longitude to 102 degrees west of longitude. The central meridian is given an easting of 500,000 meters. So the origin is going to be 500 kilometers west of the central meridian. The northing is at the equator. It's 0 in the northern hemisphere, and it's 10,000 kilometers for the southern hemisphere. Okay, so here's our zone 14 example. So we're looking at the Austin Capitol Dome, and this is a little tricky. So this line in the middle is the central meridian of zone 14. So zone 14 goes from over here at 102 degrees west, and it goes east to 96 degrees west. Okay, so the Austin Capitol Dome is 121,161 meters east of the central meridian, which means it's easting from the 0, from the origin, which remember the origin is 500 kilometers west of the central meridian. So if we start over here with our 0, we go 500 kilometers or 500,000 meters. And then we go another 121,161 meters. Our easting is 621,161 meters east. And that's how many meters east of the imaginary origin, the 0 for this grid, which is over here. It's actually off this slide, but and the northing for the Austin Capitol Dome is 3,349,894 meters north of the origin, which is at the equator. So notice the northing is a much bigger number than the easting. So pretty much if you're in the United States and you're using the UTM grid and you don't know which coordinate is your northing and which is your easting, your northing is going to be the bigger number. So the second grid system that we're going to talk about, which we actually really won't use much in the class, but it's good for you to know about it just in case you get some data that are in these coordinates, is the state plane coordinate system. And this was developed in the 1930s. So it's an old system. It has been updated, though. There's some states that have a state plane system of 1983. The original one was based on the NAD 27 datum. The new one is based on the NAD 83 datum. And the idea here is instead of projecting strips globally, what they did is they went to the United States and said, okay, let's look at each state and let's think about how we want to best project each state so that we reduce the amount of distortion in the map that we make of each state. So what they did is they chopped each state up into skinny zones, and those zones either run east-west or they run north-south depending on the shape of the state. And the number of zones depends on there's some distortion limits that are set. And so if the zone, if it got too big and you got far out of it, or far to the edge of the zone and your distortion got too high, then they had to reduce the zone. So the bigger the state, the more zones they have. And if the state runs east-west, then the Lambert conformal conic projection was used, and if the state runs north-south, the transverse Mercator projection was used. So here's a map of the zones of the United States. So you can see in Arizona, they made north-south running zones. In the state of Colorado, we have zones that run east-west. So here in Grand Junction, we are in the Colorado Central Zone. So you have to designate, so like in UTM, you have to say I'm in Zone 12 North. In State Plane, you have to say what state, and you have to say which zone within which state. Curious that Montana only has one zone. I had never noticed that before. Which projection would we use for Colorado? So these zones run east-west, so we want our line of tangency to run east-west. So we're going to take a cone, right? And its line of tangency is going to be a parallel running east-west, so we're going to use the Lambert conformal conic. Whereas for New Mexico, we want the line of tangency to run north-south, so we're going to use a transverse Mercator. These different coordinate systems are all shown on USGS maps. So if you get out a USGS quad topo map, you will see that there's the latitude-longitude grid, there's also a UTM grid, and there's also a state plane grid, so that you can find your location on a USGS map with any of those. Oh, I should mention too that the state plane coordinates are often in feet, whereas UTM coordinates are in meters. So if you look down in the collar of a USGS map, you'll see 10,000 foot grid based on this example is the Pennsylvania state plane coordinate system, the north zone. And here's the 1,000 meter UTM grid ticks, zone 18 are shown in blue. So here's a UTM grid tick, and here's a state plane grid tick. And notice the state plane coordinates are in feet, and these are in meters, and then here's our latitude, longitude.